All right, we're going to start Unit 4B. So if you haven't done so, pick these up. If you're at home, pick these up from door 1. This is what the front looks like. It says Howard real big here. It's pretty thick. In fact, I won't pull that over. But first off, starting out here, I'm going to pause the video. I want you to try these. Try to find these answers. Try to do it without a calculator. Do your best, and just remember what secant, cosecant, and cotangent are, and those are reciprocal functions: 1 over cosine, 1 over sine, 1 over tangent, and so forth. So I'm going to pause the video and I want to write my answers in. I want you to try those out on your own. Okay, so here are my answers. In fact, if you want the work, here I'll put down my work for it. You can pause your screen here. If you have any of these that are wrong, just pause it and look at my work. And if that doesn't make sense, write it down and come see me immediately. If you're in class right now, raise your hand. If you're at home, circle next to it, like ask about these, because this is a kind of foundational part of what's coming next. So what we want to do next now, we're going to be graphing these guys. And again, I'm going to do a lot of pausing the video to save time. Otherwise, this will be like a 35-minute video. And and if you want to, I want to show you why the graph looks like the way it does, because we're going to try to figure out what does secant look like if I graph it. And it's a reciprocal of cosine, so I want to show you how those are related. And if you want to go to Desmos, go to Desmos. You can just graph them, but I want to explain why, and I want you to be able to do it, without Desmos. But being introductory here, if you want to save some time, you can go to Desmos, graph it. Pause the video, go to Desmos, graph it, and then I'll explain some stuff about it. Okay, so I'm gonna pause the video. I'm gonna put in cosine. So if you want to, think about cosine, normal cosine starts at 1, pi over 2 down to pi, and it bounces back and forth like this. I'm gonna finish it with pencil. Okay, so there's cosine. Again, I use pencil for cosine. If you remember, secant. Whoops, I should be using my pen here. So secant x is 1 over cosine x. So whenever cosine is 0, I'm doing 1 divided by 0. I can't do that, and it's going to be undefined. Those are actually where some asymptotes are. So for all the zeros of cosine, I'm going to have some asymptotes. So here, in all these zeros, put in some asymptotes, because you can't do that. You can't find, we can't find the secant of pi over 2. It's undefined there. So here's all my asymptotes. I'm marking asymptotes with dotted lines. Now, if I'm at a min or a max, so say here at 1, if cosine is 1, 1 over 1 is 1, so they actually share that point. So secant and cosine share some points. Also, in fact, -1 divided by -1 is -1, so it's going to share that point too. So these are actually coordinates for secant. Now, to figure out what goes after that, if I were, let's see, so cosine, let's go this way with it. So if I'm over here and I'm really close, this is 1, so anything below this is a decimal. So down here, this is an extremely small decimal. So I'm doing 1 over a really, really, really tiny decimal, say 0.0001, something like that. Like my y value is, I'm just barely above. Well, 1 divided by a really small number is going to be a really big number, okay? It's like this one would be like 10,000. So over here, my secant is off the charts. It's way off. Now, if I say, let's go something a little more realistic, like 0.5. This y value for cosine is 0.5. 1 over 0.5 would be 2. So it's actually going to be 2 right there. So go from being way up here down to 2, and it's going to touch right here. So it comes down, it touches, and the same thing is going to happen going the other way, because I'm doing the same pattern. All of these get flipped over, and it goes up this way. So now it makes a good U shape. That was not a very good U shape that I made originally. So the red is secant. Now going this way, everything's the same except for negative. So as I'm really close to the asymptote, I'm taking 1 divided by a really small number, but if it happens to be negative, that means it's going to be a really negative big number, so it's down here somewhere. As I get closer and closer and closer, it's going to do this. And all you're going to get is a whole bunch of repeated U's and upside down U shapes. That. So the red is what secant looks like. So if you did this on Desmos, it looked weird, a bunch of U shapes going back and forth, alternating, but that's it. Okay, so now the minimum on these, and these, secant, sorry, my camera went out there for a second like it does in class sometimes. Secant and cosecant are going to have a lot in common, just like sine and cosine have a lot in common. So like the minimum on this, it goes down to negative infinity, goes up to infinity. The amplitude, there's really not an amplitude because it's as tall as it wants to be. So technically no amplitude, but for our graphing purposes, I want to talk about how far is it, because if I put like a 2 secant, then this will double in height. So the distance from that midline to the minimums and maximums is kind of like the amplitude. So this one, it's a 1 because it's a distance from the x-axis to the minimum there. And these maximums, the distance is 1 unit, sometimes up 1, sometimes down 1. The vertical shift on this one, there is no vertical shift because it didn't go up or down. The asymptotes, how we describe this, the first one is at pi over 2. And then, so we'll say x equals pi over 2 plus, and then if I go a pi later, and another pi, so n number of pi's in either direction. So where n is part of those integers. The period on this, now, so a full up and a full down, going back to here, that'd be 2 pi. So two of these together make a full period. So they're 2 pi. No phase shift. The domain on this, it's easy to describe where it's not. So all of these asymptotes are what get knocked out. So we put x equals here. Well, for domain, we'll say when x does not equal one of those asymptotes. So I'm just going to copy that down. And the range goes from negative infinity up to negative 1. And then from 1 to infinity. Okay, and so a lot of this stuff's going to repeat. So let's look down here again. I'm going to pause video and put sine in there. Okay, so there's sine. Same reasoning as before. So think cosecant x is 1 over sine x. So anywhere sine x has a 0, that'd be 1 divided by 0. So all of these are asymptotes. All of these zeros. And anywhere where sine x is 1, it'd be 1 over 1. So they're going to share all of these maximums. Same idea with the minimums. It's going to share those. And you probably guessed it, it's going to be an inside out. Basically, it's going to be, instead of a shape this way, it's going to be a U going that way. So it's going to be a bunch of U shapes going back and forth. Make some terrible U shapes here. They're almost like parabolas, but not really. They're not by definition parabolas, but they kind of look like it. Okay, so the min and max, negative infinity to infinity. The amplitude on this, well, it's technically 0, but I'm just, for the purpose of our graph, I'm going to say it's 1 because it's 1 unit away from the x-axis. No vertical shifts. Now, if you look at the asymptotes on this one, these asymptotes are 0, and then pi, then 2 pi, 3 pi. So it's just basically any number times pi are the asymptotes. So x equals any number times pi. The period is 2 pi. So after 2 pi, you get a full cycle. No phase shift on this one. We'll do that later. The domain then is going to be all the x's that are not equal to the asymptotes. So just kind of copy the asymptotes. And the range, same as up here. It's going to be the exact same thing. Okay? So I'll flip that guy over. Keep going for the sake of time here. I don't want this to take too terribly long. But a lot of this stuff is just the basics. I'm not going to do a whole lot of shifts and stuff. So right off the bat, I'll just say I'm not going to, the amplitude, actually there is no amplitude. We can say it doesn't change. I'm going to put a 1 because it doesn't really change. There's going to be no vertical shift on this one and no phase shift. So I'm not doing anything crazy to you here. But if you remember from before, tangent x equals sine x over cosine x. So for tangent, anywhere cosine had zeros, it was undefined. So think cosine starts here, it crosses there, comes down. I'm just doing the zeros of a cosine function. So I'm going to have asymptotes for tangent along these. And we did this earlier in one of the days. I can't remember what day it was, but the very last thing we did a tangent. And then if cosine is 0, you got asymptotes. If sine is 0, you got 0 over something. So anywhere sine is 0, you have zeros. Because 0 over anything is 0. So sine has a 0 here, here, basically just halfway between the asymptotes. And think, big divided, or a number divided by a big number divided by a small number is actually an even bigger number. Okay, so these are the ones that, as you're up here, and I think of a positive slope too. I think if you just want to memorize which way it goes, tangent has like a positive slope, kind of making these, I don't know if you want to call them S shapes, or kind of more really long N shapes. Okay, and now cotangent is just the reciprocal, so it's going to be cosine x over sine x. So for this, anywhere sine had a 0, you're going to have an asymptote now instead. So all of these zeros I put for cotangent are actually for tangent. All of these zeros for tangent, those are going to be asymptotes for cotangent. And then anywhere that cosine is 0, I'm going to have zeros. Whereas over here, if cosine is 0, it is asymptotes. So all of the asymptotes for tangent are zeros for cotangent. So these are going to be zeros for my cotangent. And since it's flipped over, the sine over cosine equals cosine over sine, or for the reciprocal for cotangent flipped over, and so I'm going up and to the right, I'm going to be going down and to the right. So between my asymptotes, I'm going to be going down and to the right. A lot going on in this picture, for sure. Okay, so now let's do, and this is just for cotangent. I'm answering all these questions for cotangent. The minimum is negative infinity. The maximum is infinity. And I went through all these already. Now the asymptotes, the red asymptotes are at x equals pi n, because there's a 1 at 0, and then at pi, 2 pi, 3 pi, and then going negative, same thing. Now the period for tangent, we get in the habit of putting 2 pi down, but remember for tangent, it repeats every pi. So if I'm looking at the red line here, it's going to repeat from 0 to pi is one cycle, and then 2 pi is another cycle, so that's pi. So tangent has a period of pi, so does cotangent. The domain is going to be all the x's that are not on these asymptotes, so pi times n. And then my range on this one, well, it goes up and down forever, so negative infinity to infinity. Okay. Now down here, let's say maybe pause the video and practice this. Same thing we've been doing. Go from standard to fireproof, and then describe the changes on there. I do have one thing I want to change this to pi over 4. I printed that. I didn't have pi over 4. I have shifts left 4. It should have been shifts left pi over 4. So maybe pause your video and fill these out. Try to fill these out and see if you can answer these correctly. Okay, and then here are my answers after I filled them out. So look at them carefully, pause the video, and look at them carefully, double check them. If you have any questions on these, please tell me. If you're in class right now, raise your hand. I'll come explain it better. But this is, especially these two have been, well, not all of them really, have been what we've been doing with standard form, fireproof form, and what everything means. Left side of fireproof form has to do with vertical stuff. Right side has to do with horizontal. The top has to do with shifting. The bottom has to do with shrinking and stretching. So nothing new. It's just the function itself is different, but everything else is the same.